Hi, I'm Natalie Robertson, and I'm presenting the computational analysis of common toxicants and pesticides, which was part of our class project in toxicology with Dr. Agneti. So toxicology is the study of toxicants, which are toxic compounds, and what they do in the body. But the thing is, the dose is what makes a poison. Anything in large quantities could be toxic or even lethal, but things that in small enough quantities are beneficial are pharmaceuticals. So acute exposures are going to cause problems within 24 hours. Something like a chronic exposure is your being exposed to a carcinogen over years and developing cancer from it. Toxicity is influenced by a number of factors, and this can include the dose over time relationship, the life stage of the individual exposed, where developing children are more susceptible to damage, the metabolism and rate of excretion of the individual, and the compound in the body. Physical hazards are primarily a workplace concern, but human health is a concern to all of us. Carcinogenic and mutagenic compounds can lead to cancers. Reproductive and developmental toxicities are especially of concern to expectant mothers. And endocrine disruptors, we're still figuring out exactly how those hurt us, but things like BPA in plastic are toxic. A little bit less discussed sometimes is the environmental fate of toxicants. Things that are very fat soluble may bioaccumulate through the environment and up through the food chain in tissues of organisms, and aquatic toxicity and water quality remains an issue for toxic waste. So toxicology matters because we're all exposed to toxicants. We have pesticides on our food, we have formaldehyde on the wooden tables we buy, we have flame retardants on our couches, we use cleaning products. And in addition, if you work in a place with chemicals, your workplace hazard is going to lead you to be chronically exposed to what you're working with. Also, environmental pollution affects all of us, but especially people in more of impoverished areas, people who don't have access to clean water, and we're currently living through a huge loss of biodiversity, and environmental pollution affects this issue as well. So we used in silico tools to run all of our compounds. We got them from whatsonmyfood.org, picked a pesticide, I picked Befenthrin. I got the SMILES code from PubChem, and then I ran it through all of these tools, and all of the tools, except for one, are free and embedded. If you would like me to send you the presentation, my email's at the end. So Befenthrin, it's not very acutely toxic, but it's largely a concern because it was predicted as a mutagen through the Ames test on one of those tools. It also has a log P of 6.6, which is very, very fat soluble and very likely to accumulate in the environment, and every output said that it's very likely to accumulate in the environment, so it's an environmental concern. And it is also a predicted neurotoxin, and you guessed it, it's a pesticide. It's harmful to bees, and it's also harmful, very harmful to fish, but luckily not very harmful to birds and other wildlife. So what we can do in the future is go by green chemistry, which is benign by design. And at every step in the process, from manufacturing to consumer goods, it is intended to create less toxic compounds that we're working with. We also have a major issue with the climate and pollution and the impacts of toxic chemicals creating Superfund sites and toxic waste dumps across the country, places we can't use, and places that hurt ecological and human health. And then we can help this by trying to educate people on why these issues matter, can help public health, can help people in the decisions that they make, and this computational pipeline can help anyone who wants to look into a compound they interact with. And Better public knowledge leads to us having better regulations for manufacturers and in the workplace and for what gets put on the market for consumers. So thank you for watching. If you have any questions or you wanted a copy of the presentation, I have the links embedded. Please send me an email. Thank you.